Let us try and factor a trinomial, which means a polynomial with three terms, like this one term, two, three. A trinomial that has a greatest common factor, and then it has a coefficient that's different than 1 after we take the greatest common factor out. So finding greatest common factor is always the first thing to do. So in this case, let's check the x. This term has an x, this term has an x, but there is no x here. That means they don't have x in common. Let's go with the coefficients. Well, 6, 21, and 9 have 3 in common, so we can factor 3 out. If we do, then this becomes 2x squared. And how do we know it's 2? Well, 3 times which number will give you 6? Well, 3 times 2 will give you 6. Then, if we have 21x, we factor 3 out, then that's going to be 7x, because 3 times 7x is 21x. And then, if we have a 9 and factor 3 out, then this is going to be 3, because again, 3 times this 3 will give us 9 back. Now, whenever we factor out a greatest common factor, we need to check the expression inside the parentheses and see if that can be factored some more. Maybe we forgot to factor out the greatest common factor, maybe they still have something in common, and they don't in this case. Or perhaps they can just be factored. And in this case, this expression 2x squared plus 7x plus 3 can actually be factored. And it can be factored by using so-called AC method. And why do we call it AC method, and why do we say a different than 1 right here? Well, it comes from standard form of this kind of expression, this kind of polynomial. Ax squared plus bx plus c. Now, a is the coefficient on the leading term, which is the term with the highest exponent. B is the coefficient on the linear term, and then c is the constant. And as you might have noticed, the exponents go down from left to right. So they go in descending order. So 2, 1, 0, right? So this is exponent 2, exponent of 1, exponent of 0, if you wish. So that's where this a different than 1 comes from, and then that's where AC method comes from, I mean name for it, because we actually multiply a by c and then we go from there. So in our case, a is 2, c is 3, so we would say, well, 2 times 3, right? 2 times 3, that gives us 6, and then we need to find factors of 6. Well, 1 times 6 is 6, and 2 times 3 is 6. And then after this, they would just be repeating. So now, since this is a positive number, these two either have to be both positive or both negative. Since this is a plus right here, they would both end up being positive in this case. Okay, so now what we need to do is copy our 3, because that shouldn't be lost. It's always part of the problem. And then we open 2 sets of parentheses. And if you remember from one of the previous videos, we just copy the coefficient and then x down. The coefficient and then x down. And as we said in one of the previous videos, this definitely will not give us back 2, because 2 times 2 is not 2, right? Which means we kind of multiplied by an extra 2, which tells us that we actually need to divide the whole thing by 2. Now we're good. Okay, and now from what we have here, from these numbers, we need to figure out which combination will give us 7. Well, 6 plus 1 is 7, so this is actually going to be just 6 plus 1 or 1 plus 6, doesn't matter. Let's say 6 plus 1. Okay. Now, if we look at these two sets of parentheses, this one right here and this one right here, these two terms, 2x and plus 1, they don't have anything in common. But here, 2x plus 6, they actually have 2 in common, and that's what we need to actually happen, because that's going to divide this 2 out. So let's factor that 2 out. So this is 3, the same one that we have here, times, and then we factor 2 out of here, right? So this is actually x plus 3 now. And then we didn't do anything to the second set of parentheses, so that stays. And we still have divided by 2. Now, this 2 and this 2 will divide out. So we have 3 times x plus 3 times 2x plus 1. And then these two terms right here, they don't have anything in common. These two, they don't have anything in common. We have multiplication everywhere in between. That means we are done factoring. And this is our final answer. I hope you liked the video. If you do, please click like, subscribe, and don't forget to smile.